Better pay up, it's an easy game this. After Mr. Argy's online star system have been corrupted and we search for paper coupons, the demands have been high ever since.
And you're sure those are the real deal?
Well, out of all those 150 coupons, each of them have a solid 0.8 chance of being the real one. Counterfeiting is a profitable business, you know. You can't escape it.
And so what's the probability of there being at least 10 counterfeits in that one?
You do the math.
Hello everyone and Mr. RG. I am the explainer and I will be making things easy for you or harder. Depends on your interpretation. Anyway, starting off where we left off, we heard the bad guys have a conversation before about coupons. So one of them asked of there being a probability of counterfeits. So we have here 150 coupons in a bag, where the probability of it being a real coupon is 0.8. So from there we can draw the conclusion that the probability of there being fake coupons, aka counterfeits, will be 1 minus 0.8, which is 0.2. Yay! So what can we draw, from the data that we are given? What conclusion can we draw? That it's a binomial distribution. Why? Because there's a set number of trials and also the probability is given. I don't want to restrain my sore voice too much, so I'm going to make this quick. And then continuing, one of the bad guys asked of there being a probability of there being more or at least 10 counterfeits within a bag. So it's asking if there's gonna be more than 10, including 10. So it's gonna be 10 and above counterfeits within the bag containing 150 coupons. Of course, we don't want to calculate every probability of 10 and above because it's very tiring and very stressful for our mental health. So we're going to do it the easy way, the way Mr. RG gave us, which is 1 minus the probability of there being counterfeits starting from 0 to 9. But how do we do this? What is the formula exactly? Easy! So let's say an example of there being one counterfeit within 150 coupons. So the formula is going to be 150 choose 1, which is choosing one coupon out of the 150 because one coupon is going to be a counterfeit. And then we put in the probability of there being a counterfeit, which is 0.2. Why is it 0.2 only and it's not powered to anything? Because there's only one coupon in this probability that it's a counterfeit. And then for the rest, we put 0.8 power 150 minus 1, which is 0.8 power 149. Why? Because the other coupons is real, it's not a counterfeit. So all in all, the formula is going to be 150 choose 1 times 0.2 times 0.8 to the power of 149. Easy, isn't it? You just repeat this formula for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Isn't that wonderful and easy? I don't have the capability to count it for you because frankly, I'm too tired to count it. And besides, this can be a great thinking exercise for all of you and Mr. Aji too. Continuing.
Good deal, eh?
Well, frankly, I don't got no money on me. And I've heard of this little gambling game you play, which I couldn't really care less about. But I say I take you up on your offer and I play your little game. And if I win, I get the goods free of charge.
You got me, champ. I'll play. Game's simple. Get a 7-0 space within 3 tries of the whole 52 cards in the deck and you'll get the bag.
I want to know the probability of getting it on my first try.
Well, damn. Should have paid attention to Mr. Archie. How can you not do something like this?
Hi, it's your trusty guide, the explainer here at your service again. To respond to the previous comment, why did the person not pay attention in Mr. RG's class? Maybe it's because of the rate of mental health deteriorating because Mr. RG uses gaslighting and manipulation. So, what's the probability of the person drawing the 7 of spades with his first try? But first, let's identify the problem here first. So basically, the dealer says that, oh, out of these 52 cards, you're going to have to draw a 7 of spades to win within the first 3 trials. So it's either you draw a 7 of spades on the first try, or you draw a 7 of spades on the second try, or you draw a 7 of spades on the third try. But aren't you curious what kind of distribution it is? Because it's definitely not binomial. There's no fixed set of trials. It seems to just go on and on and on. So what could it be? The simple answer is its geometric distribution, where it counts for the first success. So it has an unlimited number of trials because the trials are going to stop when the first success occurs. That is geometrical distribution. Alright, to identify the provided information here, we see that the success would be accounted for when 7 of spades is drawn, where the probability of 7 of spades is drawn would be 1 out of 52 cards, because there's 52 cards and 7 of spades is only 1 card, and the failure probability is the other 51 cards, so it becomes 51 out of 52 as its probability. Alright, let's break this down to the number of trials. Let's say you draw a 7 of spades on the first try. What's the probability going to be? It's 1 over 52. Simple. The same as getting a 7 of spades. Why? Because you get a 7 of spades on your first try. There's no failure beforehand, so the number of trials stop right then and there. But what if you get the 7 of spades on your second try? So, in this scenario, you're going to fail the first time. The first time failure would be 51 out of 52, but you're going to succeed on the second try, which is going to be 1 out of 52. So in total, the overall equation for this is 1 out of 52 times 51 out of 52, which is equals to 0.0189. Why is it 51 out of 52 times 1 over 52? Because you're going to fail first, in which the probability is 51 out of 52, then you're going to succeed, which the probability is 1 over 52. Now what about if you get the 7 of spades on your third try? This has the same logic as the one on the second try, except you failed 2 times, so it's going to be 51 out of 52 to the power of 2, because you're going to fail 2 times and then you're going to succeed, so you multiply it by 1 out of 52. So overall, the equation would be 51 out of 52 squared times 1 out of 52, which is equals to 0.0185. In total, the probability of the person to succeed in this scary game of gambling would be the total of the probabilities of succeeding on the first try, second try, or third try, which is 0.0562. Yay! Wasn't it a very positive number? Well, going on.
You know, this is my favorite part. People think they're so lucky, but then when everything doesn't go according to their plan, they all fall. This is just life's illusion to make you trip and die.
Who do you know me as?
A mafia leader? Galan, the mafia leader?
I've been trying to go for a gang for a while now, so I'll enjoy this as I watch you question yourselves to the depths of hell with maths! There's this therapy I use for occasions like this. It's quite random in brutality, but it kills fast if it turns out to be lethal to the person. The probability of it killing with a single dose is a 0.4 chance. Now let me ask you, how many people do you need to inject with a single dose of this for me to be able to kill at least one person, the probability of more than 0.9?
You love maths, don't you?
Alright, my throat is not working, so let's use my normal voice for now. So as you can see here, the problem is that the guy wants to know the least number of people he could kidnap for them for him to be able to kill with a single dose of this. So how many people he needs to kidnap before he's able to kill someone with a single dose? As we can see, the probability of it killing with a single dose is 0.4, and so the opposite would be the probability of it not killing within a single dose, which is 0.6. And then it says that the probability that he kills with at least one person is more than 0.9. Therefore, if we put this in mathematical equation, it's going to be probability of x more than or equals to 1 more than 0.9. We can expand this equation to 1 minus the probability of x equals to 0, as it's asking for 1 and above, so you can just minus probability with 0, which is more than 0.9. Further expanding, it's going to be 1 minus n choose 0 times 0.4 to the power of 0 times 0.6 to the power of n more than 0.9. And choose 0 because none of the people die within a single dose, 0.4 to the power of 0 because since there is no people that die within a single dose, therefore the probability of the killing within a single dose would be to the power of 0. Therefore, simplifying this equation, it would be 1 minus 0.6 to the power of n more than 0.9. We switch this around 1 to the right side, which is negative 0.6 n to the power of n more than 1 minus 0.9, negative 0.6 to the power of n more than minus 0.1, and the negatives and then the sign is going to flip since both signs are negative, and we're going to divide it by the negative, so it becomes 0.6 to the power of n less than 0.1. We can make this into logarithm form, which is going to be log 0.6 to the power of n less than log 0.1, and we're going to move the n down, which is equals to n log 0.6 less than log 0.1. Then we're going to divide log 0.1 by log 0.6, but look, the sign flips again because log 0.6 is negative. So it's going to be n more than log 0.1 by log 0.6, which is equals to 4.51. N more than 4.51, so the answer would be 5.
I got bitten by my one and only friend, a radioactive platypus who wore a coat, a fedora hat, and Harry Potter glasses. The effects of his math venom have affected me ever since as a serial killer.
Awesome, but the answer is 5, by the way.
How do you know the answer to this, but not when you ask for the probability of the 7 of spades? Whatever, catch.
You can die?
Do it again, we're running out of time.
Wait, what? That's not how it works. You said you'd only put it once, but you did it twice. You know you forgot to tie my other hand, right?
Oh.
So, you're not gonna untie me? Well, so what are you gonna do now that he's, dead?
Have a nice tea party somewhere else? With Michael?
Are you not gonna untie me? I know you're dead and everything, but